It's time for another amazing chemistry video with Mr. Stapleton, proudly sponsored by Farming and Nice Coffee.
Hi guys, welcome to the next video that's going to be all about naming alcohols. So I'm just going to go through showing you some structures, basic ones, adding on the previous video for naming alkenes, alkynes and alkanes. So if you haven't watched that, I strongly recommend you go back and do it, because that talks about getting some of the basics of doing some naming, and you'll be building upon that with each video. So if you haven't watched that, please go back and do it. Alright, so alcohols, basically with the naming of them, if it's just the alcohol group by itself, which is an OH, it ends in OL. Alright, so that's a really easy way to do it. So what we're going to do is follow those same steps that we had before, okay, that I talked about in the previous video. So we identify the functional groups. So obviously we're going to be identifying hydroxyl functional groups or alcohol functional groups. You'll hear those terms used interchangeably, and the reason for that, if I just move this out of the way for a second, alright, is that OH, the hydroxyl or hydroxide group, okay, is what we use to determine an alcohol. So we use the term hydroxyl in the same way that we do alcohol, and I'll show you about that when we name them a little bit. So we identify the functional groups, we count the number of carbon atoms in the longest chain, we write the name for the chain using the correct ending, alright, and we number it the same as we did before, looking at closest to the functional group. And I'll talk about what happens when you've got not just alcohol but other functional groups as well. And then we put any side chains or branches out the front. Sometimes the alcohol will go out the front as well, and I'll show you what I mean by that. So, first thing we're going to start with is just a really simple one. Okay, so what we've got here is we've got 4 carbon atoms, and I'm showing you the full expanded structures at the moment. You need to get used to using the just the condensed structures. Okay, but we identify functional groups. So here is our hydroxyl or our alcohol group. Okay, there's nothing else on the chain. There's no double or triple bonds, so it's an alkane. And we count 1, 2, 3, 4. So the fourth one is butane. Okay, but this time because we've got an alcohol function group, we call it bute. Alright, butan. So instead of the E on the end to make it the alkane, we're going to put an alcohol in. Now, it's on the first carbon, so we actually number it. Alright, 1, 2, 3, 4, just as we did before, starting with the one closest to the alcohol group. Alright, here, so it's butan 1-ol. Now, it's important to number, alright, where the hydroxyl group is, because it could actually be on this one here, which would make it butan 2-ol. If it goes to this one, it would still be butan 2-ol because it's from the same end. Okay, so that's just a very, very simple one to start with. Let's look at another one. Alright, this one I've done deliberately because it will come up a little bit later, but it's just showing how we can have more than one alcohol group in there. But we identify functional groups because alcohols are the only functional groups in here. Alright, it's still going to end in OL. So we count the carbon chain. There's 3, 1, 2, 3, like that. Okay, doesn't matter which end we start numbering from. So 3 is propan. Alright, so normally it would be propane, like that, but because we've got an alcohol function group, we don't put the E in. Alright, so it's propan, and then we start numbering. On the first, the second, and the third, we have a hydroxyl group, okay, and because there's 3 of them, we use tri-ol. So this is propan 1, 2, 3 triol. Now this actually has a common name as well, which is actually glycerol. Okay, and that's going to become important later on when we look at actually making soap, and we look at dealing with fatty acids and things like that as well. So if you can remember propan 1, 2, 3 triol, that's what we call the systematic name, and glycerol is the common name. Okay, and that's one we'll look at a bit more. But just longest chain is 3 alcohol groups, so it's triol, and we number where the alcohol groups are. Next one is where we start introducing some other functional groups as well. So we identify our functional groups. What we've got here this time is a double bond, an alkene, alright, and we've got an alcohol group here. Now, as soon as there becomes another functional group in there, the alcohol no longer determines the ending of the name, so it's no longer OL. So we name this like a normal alkene, and then we treat this as a side chain. So we number, alright, 1, 2, 3. So we look at the alkene is the one that's determining the name of it. Alright, and so we number closest to that. So there's 3 of them. Okay, so it's going to be propene. Okay, now the numbering is important in this time because normally with propene, it doesn't matter if you call it 1 propene or 2 propene, okay, because it starts at the same spot if we ignored that, okay. So if we put the double one here or here, it'd be prop 1ene either way. However, this time, because we've got an extra functional group in there, we actually need to number it. So it's going to be prop 1ene, because on the 3rd carbon we have an alcohol group, and this is where I talked about that we use the term alcohol and hydroxy interchangeably. When it becomes out the front of the name rather than the ending, we call it hydroxy. So this is 3-hydroxy prop 1ene, okay, and that's showing that the double bond is starting on the 1st carbon, all right, and the alcohol group, the hydroxy, is on the 3rd carbon. That becomes very important when we start naming it. Onto another one. Okay, what happens, okay, if you've got alcohols like this? How do you start naming it? Okay, well, hopefully this will be very, very similar to what you thought with the glycerol, the propan 1,2,3-triol. So we'll look at this again. We've got 4 of them here. All right, so it's going to be butane. Okay, and then we have a look, and this end here is going to be the 1, 2, 3, 4. Okay, so here we're on the first one, we've got 2. Okay, all right, on this one we've got the 3. So we have to number it again. So it's butane 1, 1. Okay, so there's 2 on the 1, and then there's a 3. So butane 1, 1, 3. Okay, and this time it's going to be triol. So we don't, because we come back to just having the hydroxyl groups on their own with no other functional groups, we don't put a hydroxy out the front. We go back to naming it with an OL on the end, right? But we number them again. Okay, so hopefully just showing you that, to keep that in mind. What I'm going to do now is sort of go the reverse. Okay, so I'm going to start giving you some names like this: 2,3-dimethyl-hexane-2-ol. So starting to put these together and kind of going backwards. All right, so we've got the name. What you need to do when you've got the name is identify the carbon chain. So here, we just don't worry about this to begin with. We look at hexane-2-ol. So we look at hex. Right, hex means 6. So we've got 6 carbon atoms. So the first thing we do is we draw out our 6 carbons. Just like this. So always suggest you put in your chain first, your skeleton structure, and then start working your way through the name. Okay, hexane-2-ol. Always easiest if you work left to right. So on the second one, we've got an OL, an alcohol functional group. So we're going to go OH. I'm going to take a moment here to talk about bonding. That's really, really important. The carbon bonds to the oxygen, so you need to show that when you're drawing the structure. Don't put the bond here in the middle. So actually, if I rub that out, if I draw it like this, okay, that's what is called a sloppy bond, and you get penalised for that in the exam because that looks like it's almost bonding to the hydrogen, which doesn't occur. So make sure when you're drawing out your bonds, you show it really, really clearly that that's OH, like that. Okay, so we've taken care of the 2-ol. So that's actually hexane-2-ol there. We haven't just put the hydrogens in yet. So now we start having a look at this. 2,3-dimethyl. So di tells us that there's 2 methyl groups. Methyl is 1 carbon. So it comes on the second and the third one. So on the second one we're going to have a CH3. Notice I've got the carbon to carbon bond occurring again. And on the third one we've also got a methyl group. Now it doesn't matter if you put it down or if you put it up. I'm just going to put the methyls next to each other like that. So we've got 1, 2 carbons. Alright, hexane-2-ol, 2,3-dimethyl. Okay, then what we're going to do is just start putting in our hydrogens. So H. If you want to condense these down, you can. Okay, and the key to remember is that every carbon must have 4 bonds around it. Okay, so there we go. We've now drawn up 2,3-dimethyl-hexane-2-ol. Alright, you start with your carbon chain and you start building up like that. I'll show you another one. Last one I'm going to show you is this one. 4-methyl, 2-hydroxy, hex 1-ene. Okay, so you go through the same process. Okay, hex, alright, hex means 6 again. I just happen to have chosen 6 for both of them. Sorry about that, but it doesn't really matter. So hex is 6 of them. 1, 2, 3, 4, 5, 6 of them, just like that. Now we have a look. 1-ene. Ene indicates that it's an alkene, a double bond, and it starts at the first carbon. So I'm going to put my double bond in there on my first carbon. Now I start working my way through, and I'm just going to go left to right. So I've numbered this number 1, going left across, so 4-methyl, 1, 2, 3, 4. So on my 4th carbon, I have a methyl group. Okay, and then 2-hydroxy. The hydroxy is the alcohol group. So on the 2nd carbon, I'm going to put the OH. Again, carbon to oxygen bond, not the other way around, carbon to carbon bond. Now you go through and put your hydrogens in, because we've worked our way through. And remember, the key is 4 bonds around every carbon. So this has got 1, 2, so we need, now, I'm going to draw it like this, H, H, because if you go back to the first topic, it's a trigonal planar arrangement, but if you put it up and down, then it's going to penalise you. Have a look at this carbon, 1, 2, 3, 4 bonds around it, so we don't need any more. This one's got 2, so we need hydrogen, hydrogen, like that. This one's got 1, 2, 3, so we need a hydrogen there. We need 2 on this one, and we need 2 on this one. Always what I recommend you do when you've drawn a structure is you go back and check, count that each carbon has 4 bonds around it. You don't want to make a silly mistake. And then check that this matches up your name. So go backwards. 1, 2, 3, 4, 5, 6. Okay, it's a hex alkene functional group. So hex 1E, because it's on the first one. 2-hydroxy, 4-methyl, 4-methyl. Yep, got all that in the name. Okay, that's the best way I can help you in terms of being able to go from the name to a structure. So check, you can go both ways. I suggest you go back to the video, pause it before I go through and either name them or draw the structures, check that you can do it, and then work your way through your essentials workbook, try and do as much as you can. Hope this helps, guys. Next one I put up will probably cover aldehydes and carboxylic acids together. Practice, practice, practice. Best advice I can give. See ya.